Hello, Algebra 2, how are we doing? We're looking at 10.2, more trig function stuff, and there's a chance I could ramble and this video is forever long, or there's a chance that I don't end up rambling and it's not that long. Sometimes I just get into it, sometimes I don't. Let's see what happens. We're looking at more graph stuff, okay? So here's our sine function. I've pre-graphed it for you. It starts at 0, goes up to 1, works its way back down. Here's cosine. Starts at 1, works its way down, and then goes back up. And then from here, it just repeats itself and repeats itself, right? And from here, it just repeats itself and repeats itself, okay? So this piece here, this piece from beginning to end, that is called a period, okay? The length of this, the length of from 0 to 2 pi, that distance is called the period. This distance from here to here is called the period. The period for all of our functions have been 2 pi that we've been graphing. We've been stretching them or smushing them, but the fact of the matter is the length has been 2 pi. But we can smush it this way as opposed to smushing it, or instead of stretching it out this way. So let me pause for a second. Okay, I'm trying to be fancy and use Desmos on my iPad so we can do two things at once here. Here's our regular sine function, right? I can come in here and type a number here that stretches it out, makes it even taller, makes it even taller, right? But in the end, the length of this function, or the height, the length of this function is still 2 pi. The length of this function is still 2 pi. And you can see that, okay? Now, the second I put a 2 there in front, you see how this function all of a sudden it's doing the curve from 0 to pi. It went up, down, and back to the middle from 0 to pi, and it's already repeating itself. Now there it is at 2 pi, repeating again. You see how the squiggle is happening quicker? You see how the squiggle is happening quicker? So we've shrunk the period. Instead of it being more stretched out and going from 0 to 2 pi, it's now been accordion smushed in and it's going up and down and it's ending at pi. So the length of the period has changed from 2 pi to pi. I could type a half here instead. And now look, it's longer. It's taking longer to perform that curve. It starts at 0 and the curve doesn't end until 4 pi. It goes up slowly, down slowly. So we're changing the period here. I hope you see what I'm stressing there, right? It either goes up and down quick or slowly. And so we're changing the period. So over here, we can solve for the length of the period by doing this. So this b value is going to be in front of our x, okay? And you take 2 pi and you divide it by b, and that is your new period, okay? So when you have, we know that the period for sine of x, is 2 pi for the red function. The period for this one is 4. You see that? 4 pi. Because when you take 2 pi and divide it by a half, dividing by a fraction is the same thing as multiplying by the reciprocal. You end up with 4 pi. So our new period is 4 pi. And when I put a 2 out in front, that's why it's shrinking it. It's making the period smaller, right? It's happening quicker because 2 pi divided by 2 is simply pi, which is why our period here is only pi long. Let's hide the red function. You see that? How it went up, down, and then ends right there at pi. So the length of the period is only pi long. Okay? I know I'm saying pi and 2 pi a lot, but that's what we're really focusing on. And 2 pi divided, what if I make it a 3? Well, let's change our step here to pi over 3. It'll make it more obvious. 2 pi divided by 3, well, that's just going to be, that's just a fraction, 2 pi over 3. So you can't reduce that. So you can see the length, look at this. You see how our function starts at 0 and ends at 2 pi over 3, and then it starts to repeat itself? So we've changed the length of the period to 2 pi over 3. I can make it 4. What's 2 divided by 4? A half. So now the period is half a pi. Change the step to pi over 2, make it a little more obvious. Now the period is half a pi. You see that? I don't know why I can't click on the function. There we go. Boom. So that's how it changes things. And again, I encourage you to fiddle with Desmos and discover this for yourself. Okay? So we can obviously just plug these into Desmos and it'll give us a good picture, but I'd like to ask some questions here. You know, some things that we need to be thinking is, all right, our A value is the amplitude, and this new B value is the length of our period, okay? So there is no A value, so our amplitude will still be 1, okay? And our new period is going to be 4 pi, okay? So here's 0, pi over 2, pi, 3 pi over 2, 2 pi, where before, you know, actually I didn't space that. Let me pause real quick. Okay, I just wanted to quickly write down those values, where before it was going 0 up to 1, then 0, then -1, then here, right? That's our regular old sine function. But now, because our period has been increased to 4 pi, it's going to start at 0 and end at 4 pi. So this has been stretched out like so. You see that? That's what's happening. The second you put a half here, you're starting to make it longer. Let's do it again. I'm going to pause again. I wish these were labeled. Hold on. Okay, and I'm back. So what's happening here? Our amplitude is 2, and what is this 4 doing? This 4, oh, I just realized this was cosine. Oh shoot, I did that wrong, right? I'll fix that in a second. So this is sine, and our period, 2 pi divided by 4, that means our period is only half a pi. So where before it would start at 0, let me use a different color so it stands out. We would start at 0, go to pi over 2, pi, down to 3 pi over 2, and 2 pi, right? That's what it normally does. Well, now our period is only pi over 2. It's rather tiny. And also, at the same time, our amplitude is 2. So it's going to go up to 2. So it's going to start here, end here, and then go like this. I don't even have enough room to do that beautifully, right? So it's going to go up to here, down, down, right? Something like that. So we stretched it to have an amplitude of 2, and then the dividing by 4 shrunk our period down. So, you know, a whole bunch of these would fit, you know, inside of, how many fit? 1, 2, 3, 4, because we divvied it up by 4. We divided by 4, so this function fits 4 times. You see that? Let me go back and fix this. So cosine starts at 1, then goes to 0, then goes it goes, so starts at 1, goes to 0, then goes down, down. So like that. Yeah, it goes like that instead. And now our cosine is going to be something like like that. It's elongated. I mean, we're all going to use Desmos, right? But I'm just trying to show you how it's stretching out. That's what I'm trying to depict here. Okay, so I obviously can't ask you to graph as a question, but I'm going to ask a question here about C. I would like you to tell me The amplitude, this one's too easy. I would like you to tell me the amplitude and the period. Okay, you'll have some multiple choice options, and I'd like you to tell me both. Okay, some options pop up on screen right now. And what do you notice? Well, immediately that 3 should tell you, boom, the amplitude is 3. Amplitude is a distance. You can't have a negative amplitude. So the amplitude is 3, positive 3. And our period, well, you take this number, 2 pi divided by 2. Our period is pi. Okay? So where our function would have gone from 0 to 2 pi, right? It would have done something like this. We've now flipped it and stretched it, and we've shrunk the period to pi. So it's going to start here, go down to 3, there, there, there. See that? We stretched it and went down to 3, and it needs to start and end at 0 and pi. Yeah? I encourage you to use Desmos. Okay, you can punch Desmos and see all of this in action, which let's just punch this one in for grins here. We've got, let's have our sine x, and then let's make this -3 and 2x. You see that? So right there you can see that's exactly what I plotted right here. Okay, you've got, it starts at 0 and ends at pi, just like mine does, and then it goes again, pi to 2 pi. So two of the ups and downs fit, whereas the original function, which is the blue one, starts at 0 and goes to 2 pi, right? Okay. So that's why I said this lesson was going to be rather short, because we're already used to amplitude. We already know how these functions sort of behave. It's just that now, instead of stretching them this way or smushing them down this way, we're also trying to stretch them out this way or smush them in this way. Okay? So these problems are going backwards. I like the going backwards problems. So let's make an observation. Our amplitude is at 4. And there is a single period. I want you to, take the time to highlight, like, okay, up, down, back to the middle. Okay, right? There's a single period. So instead of it being 2 pi, it's now pi. So what did we do? We divided by 2. We took half of it. So our period is pi, our amplitude is 4. So 4 times sine of 2x. Why the 2? Because when you take 2 pi and divide it by 2, that gives you the pi. Yeah? Let's do another one. Cosine here. It's starting at -2. Cosine usually starts at +1, right? It looks something like this. And that's at 1. Well, now it's starting at -2. So it's been stretched and flipped. And our period is now going, it's starting at 0 and ending at 6 pi. That's much longer than normal. It went from 2 pi to 6 pi. How do we do that? Well, we multiplied it by 3, yeah? So that means our period is 6 pi, and our b value is 2 pi divided by b equals 6 pi. Right? What is this b value that we're dividing by? 1/3. 1/3. Yeah? Because when you divide by a fraction, you're multiplying by its reciprocal. 2 pi divided by 1/3 is 2 pi times 3/1, giving us that 6 pi. Okay? So your period gets longer as this b value gets smaller. As this b value gets smaller, your period gets bigger. As this b value gets bigger, your period is getting smaller. Last question, and we're practically under 15 minutes, but not quite. That's okay. Last one. I'd like you to just choose the right equation. You need to observe this graph. What is the amplitude? What's the period? And come up with this equation. There's going to be some options on screen for you right about now. So you observe that the amplitude here is at 3. It's 3 tall. 1, 2, 3. Yeah. And the period, it's starting here and then, right back to the same spot and right back to the same spot. Now, what sucks and what made this problem harder is, okay, well, what is this value right there? What is that? Like, how long is that? I don't know. But this was honestly a tough problem. I wonder how many of you got it right. Good job if you got this right. How many are, this is 1, 2, 3. 3 of them are fitting inside of 2 pi. So we took that 2 pi and divided it up by 3. So there are 3 of them fitting inside of the 2 pi. So you guessed it, our period is 2 pi over 3 because 3 of them fit inside of the 2 pi. Does that make sense? 3 periods fit inside of 2 pi. So each one must be a third. 1/3, 2/3, 3/3. So 2/3. So therefore our equation is, it's also in the negatives. So -3 cosine of 3x because we're taking 2 pi and dividing it by 3. That's our b value. And with that, not too long of a video. Wasn't the shortest video of all time, but not too bad. I appreciate you watching. I appreciate your time. I shall see you in class.